Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem number 1861, rotating the box. Another matrix problem from this week. Here in this problem statement, we will be given a m cross n matrix of characters box. And they are saying that in this matrix, we can only have three types of cell values. First one is a hash, and second one is a star, and third option is a dot. If we encounter a hash value, it means that value or that cell represents a stone. If it is a star, it's an obstacle, and if it is a dot, it means it represents an empty cell, like this. And they are saying that we are rotating the grid by 90 degree clockwise. So if we rotate the grid 90 degree clockwise, all of these stones are going to fall due to gravity. Gravity does not affect the obstacle position, that is also given. It means that only the stones are going to fall due to gravity, and the values of the obstacles cells will remain the same. Let's have a look on this example. Here we are only having two stones on the first and the last position. If I rotate this box 90 degree, it will look like this after the rotation and the gravity is applied. And what we have to return from this function is return a n cross m matrix representing the box after the rotation and this second operation, that is a gravity. So we will be given a matrix which is called a box, and on that box we need to make a 90 degree rotation, and after that we have to apply the gravity. So all the stones will fall below due to gravity, and obstacle will remain the same. So after these two operations, whatever the value is, that we have to return. If I try to show you on the first example, the input is like this: hash dot hash. These two are the stones and this is the empty cell. If I rotate it by 90 degree, it will become this. And after I apply the gravity, this stone will remain at this position. This empty cell will be filled by this stone. So the state will become like this. Then the first position will be the empty cell now. This matrix we have to return from this function. Okay, so how do we approach this problem? First of all, let's try to have a look on the brute force solution. It means that whatever mentioned in the problem statement, we'll try to do that. We are mentioned two operations. The first one is that we have to rotate it by 90 degree clockwise, and the second operation is we have to apply the gravity. Let's try to apply these two operations on our second example. In the second example, this is the box given to us, and in this box you can say this is a m cross n box. Here we have m number of rows and n number of columns, but after 90 degree rotation, that is after the first steps, the box will look like this. It will be n cross m box. It means m rows will become the m columns and n number of columns will become the n number of rows. If you try to have a look, and here this rotation is a clockwise rotation, it means that this first row will look like this, will become this. Row 0 will become the first column here, and the row 1 will become the 0th column here. Firstly, let's try to have a look on the columns in our initial matrix. In my initial matrix, let's say I have a look on this column. This column is the first column, and in the resultant box, this first column is becoming the first row. Now let's try to analyze that this first column is going to become the first row, second column is going to become the second row, and third column will going to be the third row. So here it is clear that the column, let's say the column is something like, let's say the column value is j. So j column will become the jth row in the resultant grid. As given to us that our initial box is of this dimension, box m cross n. If I try to have a iteration over it, so the I value will go from 0 to m and j value will go from 0 to n. So this is the for loop. So double for loop I have applied. And now I need to fill this matrix using this matrix. And this matrix is my box matrix. Box matrix where row value is I and column value is j. And let's say this matrix is my resultant matrix. Here this is the row and this is the column. Now when we analyzed this matrix, we found out that the first column is becoming the first row of the resultant matrix and second column is becoming the second row. If we try to have a look on the indices, column with index 0 is becoming the column with row with index 0. So the column here this is the column. So the column will become the row and it is becoming the same number of row. Jth column will become the jth row. Okay. And what about the row? What about the column? Here we saw that here this row is of index 0 and this 0 index row is becoming the last column. And how many rows we were having in the starting? We were having m rows. So m rows means row indices will go from 0 to m minus 1. And if the 0th row is becoming the last column, what is the last column? Last column will be m minus 1. So 0th row is becoming m minus 1 column. So this is row. So what will be the first row? First row will be m minus 1 minus I and I value is 1. So which is m minus 1 minus 1 and second row will be m minus 1 minus second. So the ith row, or let's say it is k, kth row will become m minus 1 minus k. So here this is the row and the row index is I. If the I value is 0, it will become, it means it is a first row. First row is going to become the last row. Last row is m minus 1 and the kth row is going to become m minus 1 minus k because this is the last row and last column and the previous columns are all also going to have a less value. So m minus 1 minus I. So this logic is going to show that the rotation part. Now my box is going to be rotated by 90 degree clockwise and the answer is going to be stored in the resultant matrix, and the resultant matrix is of size n cross m. First part is done. Now we have to apply the second part. Second part is here where we applied the gravity. When we applied the gravity, all the stones are coming down. For gravity, let's have a look. Let's consider the first row. First row is hash empty, then obstacle, then empty. Hash empty, then obstacle, then empty. So this is the first row. First row is going to be the last column. Let's make it a last column. Hash 0 star dot 0th row and this is m minus 1th row. So now the first step is done, which is rotation, and in the rotation is going to be done using this formula. Okay, now we come to the second part. Second part is we have to shift the stones. Only the stones will be shifted. Obstacles are not going to be shifted because they are fixed. They are gravity proof. And the stones will be shifted to the down, and they will be shifted to the next available or maybe suitable empty cell. And when we are applying gravity, we will start filling from bottom to top. And this is the resultant matrix. Resultant matrix was of size n cross m. And here we are going to have n rows, and n rows will be from n minus 1 to 0. And we will start filling from n minus 1, will go up. So first of all, we will only manipulate a cell which is already empty. Let's say we are at this cell. Do we have to do anything? We don't do anything. If we directly encounter, let's say we directly encounter hash, a diamond, then we also do not have to do anything. But if it is an empty cell, then we will do something. If we encounter the empty cell, we will do something. And what we will do is, let's say at the ith index, we encounter the empty cell. For every empty cell, which we will try to see, we will try to find the stone cell above it. Stone cell from above it, which it means if we are at I, we will try to search from I minus 1 till 0. We will try to find an index k where this k is having a stone. Okay. For I minus 1 to 0, find stone position. Okay, let's say while finding the stone position, if I encounter a star, that is an obstacle. If that obstacle is encountered, it means we have to discard everything. We do not do anything. And we will just directly jump to the next step, or maybe next empty cell. So here, if I encounter an obstacle, what I will do is, I will just, for now, let's just do one thing. Whenever we are encountering a obstacle, we'll just ignore that. It means we are not able to find any suitable diamond cell above it. We'll just continue it. So after this operation, we will definitely have a diamond cell position. Let's say we are initializing k to minus 1. If the value of k is equal to minus 1, it means we are not able to find it. If k value is not equal to minus 1, we have found it. And from that diamond cell, what we'll do is, we have found the value of k. K is the diamond cell, and this is the I. So here, if we have found the stone cell, the empty cell will become the hash. That is a stone. Empty cell will have the stone, and that stone cell will have the empty cell. The stone cell will become empty. So after this step, if we have found the value of k, we already have I. Initially I was empty and k was having a stone. Now I will have a stone and k will become empty. Okay, so this is we have to do. And here what I did is, I took a row, and in that row I'm going from bottom to top. Bottom is n minus 1 to top. And for every value of I am searching for any suitable diamond position in the up direction. So this is going to be n square time, and this I'm going to do for every rows, and I'm having m rows. So the time complexity of this operation is going to be m rows into n square. So this is going to be the time of my gravity operation. So all those two operations are done. 90-degree rotation is done. It is going to be done in m cross n time using this formula. And that applying gravity is also done, order of m into n square. Okay, but this is going to be the brute force. We will try to see further how we can optimize it, how we can optimize the gravity operation. For now, let's just try to code this approach. Let's quickly write the code for this approach. First of all, I will take m cross n variable. I will take another resultant matrix of size n cross m, new char n and m. Now I will do my first processing, which is rotation, and then my second step, which is applying gravity. And after both the operations are applied, I can directly return my result. So what about the rotation? Rotation means I will be, for rotation, what we discussed is that I have to iterate over the box and apply our formula. To iterate over the box, I have this nested loops. Okay, so this is the template, and the jth column in the given matrix will become the jth row. Fine. And ith row in the given matrix will become the m-1 minus ith column. Okay, now the rotation part is applied, and for the gravity we have to process every row of my result. And for rows, we usually take j equal to 0, j less than m, j plus plus. For every row we are going to process every column from bottom to up, because gravity is coming down, and we'll try to start searching from bottom to up. For int, during the processing of every row from bottom to up, we will see if the current position is an empty cell. Only in that case we will try to look for the next stone position. Let's take the pointer k for searching for the next stone index. For k, and k will be i-1 and k greater than equal to 0, k minus minus. To store the position of the next stone, I will take another variable. Let's call it stone, initializing it with -1. And here I might have two possibilities. If I encounter an obstacle, if that is an obstacle, I'll just discard it. I'm going to continue in that case. And if it is not an obstacle, if it is a stone, then just capture the position. If it is a stone, then just capture the position. Position is I. And after this loop, I will see if the value of stone is not equal to -1. That is, we have captured the stone value. If we have captured the stone value, so the result ij, the initial position which was blank, will now have a stone, and this position result, the stone position in the same column, will have an empty cell now. Now the processing is done. I will try to run over sample test cases. Okay, so what's wrong here? Here I am in the nested loop. I am also using k. So using I instead of I should use k here. K is the pointer for this loop. Now let's try to run it again. Running fine. I'm submitting the problem. This is submitted successfully, but here the time complexity is going to be order of m rows into n square. So to optimize it further, we have to use two-pointer approach. Let's have a look on that. In our current approach, when we are applying the gravity operation, here first of all we are iterating over every column, and every row we are processing from bottom to up. And while processing every column from bottom to up, we are taking another variable k, and that is we are using to find the next possible position of stone. So this inner loop operation is going to take n square time because of this introduction of this loop, and the outer operation is going to take m. So ultimately the time complexity here is going to be order of m into n square. But we have to improve it further. This time complexity we can improve further by using two-pointer approach. Here in this case, let's say this is my one column after the rotation, and here we will be using two pointers. What are those two pointers? One pointer is the I value, and I is the iteration pointer of that column from n-1 to 0, because we are processing each column from bottom to up. And apart from that, we will also keep track of a variable, or you can say pointer, lowest, and this lowest pointer is going to track the position of the lowest empty cell. Let's try to run up this example. Here value of I is this initially. This value is empty. If this value is empty, we don't have to do anything. We'll just keep on moving further. Now value of I will become this, and here initially the lowest pointer is pointing to this one, lowest pointer at this. So when the I value is coming here at this position, here it encounters that this is a obstacle. If this is an obstacle, it means that lowest position, the lowest empty cell position after this obstacle are no longer valid. This portion is discarded, and this lowest possible value should be pointing to this one, I minus 1. So if we are encountering an obstacle, the lowest value will become I minus 1. So this is one case. Another case is when we are encountering a stone. If we are encountering an empty cell, then it is fine. Just move further. When the value of I is coming here, it is encountering hash value. Hash value means it is a stone. So if it is a stone, the stone will be shifted to the lowest empty cell. The stone value will be shifted to the lowest empty cell. So lowest empty cell is this. So this will become hash, and the current value will become empty. Current value will become empty, and the current stone will be shifted to the lowest empty cell. Current lowest value is used, and the lowest value will be decremented by 1. Lowest minus 1, or you can say minus minus. So this is going to be our 2 pointers approach, and in this case we are just iterating my column from bottom to up only once using 2 pointers. So both of these pointers will be traveling n times, so it will be m plus n plus n. So ultimately the time complexity of doing this operation on every m rows will be m cross n. Okay, so the time complexity of whole operation will be order of m into n. Now let's try to write or optimize our current code. Let's optimize our current code as per our pseudocode. Here, first of all, we are going to iterate over every column, right? And then for every column, we will iterate row wise from row n-1 to 1. Before we are starting for every column, I will be initializing this lowest value with, let's say, initialize it with the last value. And now here I will check the current value if result of I and j is equal to an obstacle. If it is an obstacle, the lowest value will be equal to I minus 1, because till I everything is wasted. And if result of I j is equal to a stone, if it is a stone, the lowest is going to point some value, and the lowest value will going to have this stone, and this stone value is going to be empty. So result of I and j will be equal to dot, and the result of lowest and j will have hash, and the value of lowest will be decremented by 1. I think that's all we have to do for the gravity part. Now let's try to run our sample test cases. Sample test cases are passed. I'm submitting the problem again. This time it is way better than the previous solution, and the time complexity here is order of m into n, using this 2 pointer approach while applying the gravity. Hope you understood the problem. Thank you guys. Bye bye.